Hey Monsters, coming to you once again from the basement for this week's Teach From Home lesson on waves. So this is the week of April 27th to May 1st. This video, of course, gets posted on Friday afternoon, but it is for next week and it's due by Friday. Just kind of touch on what we're doing. The standard is listed on the choice board. I'm going to jump right into what the objective is so that we can actually fit that on the screen here. I can use wave equations to show the relationship between velocity, wavelength, and frequency, and I can label the parts of a wave which are measured. So we're going to go ahead and take a look at those wave equations, take a look at a drawing of a wave and what the parts of the wave actually look like, and then with any luck we're going to go ahead and try to do a quick demo of some waves so you can kind of touch on those skills as well. With any luck, the goal obviously is to cover all of the things that are on the different four choices at the choice board. There is a separate video that reviews the choice board, the full HyperDoc for this week, should you want to take a look at that. That was, of course, done with Screencastify, and it is linked into your choice board right near the top where it says HyperDoc Assignment and Choice Board. There's a video review with Digital Niwame in case you need to see that. So if you're interested in that, it's right next to the Bitmoji that says, "How's this work?" on your HyperDoc, and you can go ahead and take a look at that to get more details. I'm going to jump in with the actual lesson part and try to hopefully get you some of the skills that you need. So we're going to take a look first at the waves equation. All right, so for our waves equation, we like to use this triangle. We use this a lot in class as well because it shows you how to do the different equations. If we're looking for the velocity, we are going to multiply straight across wavelength by frequency. We'll discuss a reminder of what those terms are in just a second. And if we are looking for the wavelength, we're going to, remember in class we were doing the cover-up thing, so then velocity divided by frequency. And if we are looking for frequency, we're going to cover that up, velocity divided by wavelength. First one I didn't actually do that. If we cover up velocity, we can see we're doing wavelength times frequency. So what are these terms? The velocity, as the definition shows here, is the speed. It's going to be measured in meters per second. And actually switch to a blue marker for that. Okay, velocity is measured in meters per second. Frequency is measured in hertz. And I'm writing the abbreviations for these on here so you will have them. And then wavelength is measured in meters. So that's what we're looking at with those. We're measuring velocity in meters per second, frequency in hertz, and wavelength in meters. When you're doing the assignments related to this, so for example, if you're taking a look at the pretest diagnostic, or if you already did, or if you're doing one of your final activities, you are going to want to make sure to include these units with your answers. So real quick, we're going to go through what these terms actually mean, just to make sure we know what parts of the wave we're looking at. And then we're going to do a few waves equations together, just to get some added practice. So hopefully remember we have two kinds of waves. Did draw both of them here on the coaching board. The top one is going to be a longitudinal wave, which means that it is the long way. That's kind of how it moves. And the bottom one is going to be the transverse wave. So remember with the longitudinal wave, it's moving straight down the line like this. And with the transverse wave, it's moving across because trans is across. Longitudinal is going to be that long. So let's go ahead and take a look at those waves vocabulary words. The velocity is simply how fast this wave is moving. So on either one of these waves, it's how fast it goes from this end of the clipboard to this end of the clipboard. For the frequency, it's how often a wave goes past. So let's say I'm standing right here at center court. I'm going to go ahead and draw a little tennis player on there. Got his racket in hand. Okay, so little tennis player's got his racket. It's how often a wave goes past that guy at center court. That is the frequency, and that again is measured in hertz. We have that on this other board still. Okay, and the last one is going to be wavelength. So that's measuring from the same point on one wave to the same point on the next wave. So that's going to be looking at, let's say, from the top of one wave to the top of the next wave. This is wavelength. And same thing, it could be from the middle of one compression to the middle of the next compression. And for this one, we're going to use a symbol for wavelength, which is that lambda. So that's going to look like this. Wavelength on the bottom wave and wavelength on the top wave. For both of them, we're doing a similar thing. We're measuring from crest to crest on the bottom, and we're measuring from compression to compression on the top. Those wide bubbles in the longitudinal wave, remember that it's called a rarefaction. That is what we're looking at with those. Those are rarefactions. So the key part, when we're labeling waves, we're actually going to be looking at one of those transverse waves. So I'm going to go ahead and go onto the other side of the court. We're going to draw a bit, actually there's tuning lines on there. We're going to go ahead and go back to this board. We're going to draw a big transverse wave on here so we can get some labels on there and hopefully have it make some sense. All right, so now that we have our wave drawn on here, you can see we have a black wave transverse going across and then a blue dotted line going through the center. That dotted line is the center of the wave. That dotted line is known as the rest position. Basically, that dotted line is where the wave would be if it weren't actually waving right now. If you think about ocean waves, you know, when we draw them as a little kid, they kind of have that curvy look. Mine look a little bit like a school of sharks swimming by. So that is what the ocean would typically look like when we start to have some drawing skills. When we're even younger, though, we just draw a flat blue line for the ocean. That flat blue line in front of our shark tail or shark fin waves, that's like the rest position down here, that dotted line. So the rest position is where the wave would sit if nothing was going on. You think about when you see like a heart monitor on a TV show and it goes boop, 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 boop. When the guy on TV died is going to be when it's at the rest position. And usually they don't die on TV. They just kind of move on from that. So then our top of the wave, this part right here, whether it's the top here or the top over here, it doesn't matter. But we do know that this is going to be the top because of how I've been drawn on the board. This is the top of the board. That top of the wave is known as the crest, just like the toothpaste. Remember we talked about in class, Crest toothpaste named itself because they wanted to say they are the top toothpaste. That's going to be one of your, kind of your mnemonics there. Or you may have heard the term crestfallen. That's when someone is feeling like their dreams have been dashed or their success has been kind of put down. That's because they've now fallen back down here to the rest position. So crest is going to be the top of that wave. In contrast to that, the antonym of the crest, the bottom of the wave, is the trough. So think about the trough as like when we think about where pigs eat out of, or if you dig a ditch in your yard, that could be known as a trough. So the trough is when it goes down. It's below the rest position, all the way down at the bottom. That is the trough. Now, the distance from the rest position to the crest, or the rest position to the trough, I'm going to put both these up on the screen. That distance there, that blue arrow, that is known as the amplitude. Whether you're going up or down, that is the amplitude. And it is the same in both of those situations. Not just the same vocabulary word, but it should also be the same distance from the top to the bottom. If I got out a ruler and measured it on my board, we probably would not find it's the same distance simply because I'm a very bad artist. But that is the amplitude, and it should be the same distance going from the top to the top, or I'm sorry, from the top to the middle, or from the middle to the bottom. That's going to be your amplitude. And we already have written down the two examples of wavelength on the half court here. And so we can see there our reminder. Our wavelength is the distance from one point on a wave to the same point on the next section of the wave. So the wavelength could actually be measured from anywhere on the wave. Typically, though, we're going to see it in a transverse wave measured from crest to crest or trough to trough. And in a longitudinal wave, we're typically going to see it like we see here from compression to compression or you could do it from the center of a, no, I drew a blank on the word, center of the wider part to the center of the next wider part, the rarefaction. So from the center of a rarefaction to the center of a rarefaction, that also could be the distance that you measure for wavelength. It does need to be always from the same point. If I measure from here, which would be perfectly fine, the same point on the next wave is all the way over here. It needs to be back to that downward turn. So this little section is not a wavelength. This distance here is a wavelength. Hopefully that makes sense for what you're looking at there. And then to finish out for this lesson, I do want to do some examples of using the waves equations. So I'm going to put a couple down on the board. We'll pull them up, flash them up like this, like we're playing Classroom Jeopardy, and then go ahead and take a look at what the answers are going to be using our triangle equation. That's our equation, and I'm going to actually, I got a picture of this. I'm going to freeze up on the screen up over here. Our velocity, wavelength, and frequency in that triangle equation to show us what we're going to do with it. And so I will re-reference that as needed. Find the wavelength of velocity is 25 meters per second and frequency is 5 hertz. It's going to be our first question. So since we are trying to find the wavelength, we are going to cover up wavelength and see that we're going to divide velocity by frequency. So let's go ahead and take a look at what that'll look like. Divide velocity by frequency. 25 divided by 5. And hopefully you know that that answer is going to be 5. But then, of course, we want to make sure we include units. And so since we are looking for wavelength, it's going to be 5 meters. 5 meters. You're going to have to write that lowercase m next to it. Find the frequency if velocity is 100 meters per second and the wavelength is 20 meters. Intentionally keeping these a little simpler. So now we're finding the frequency. Bring our equation back up. We're going to cover frequency. We see that it's going to be velocity divided by wavelength. So V divided by lambda, you go ahead and write out the full equation on this one, equals our velocity is 100 meters per second, and I am intentionally doing this a little bit differently than I did the last one. 100 meters per second divided by 20 meters. Of course, we could just cancel out our zeros. I think you are familiar with that trick from when we've used it in class. Cancel out our zeros makes it 10 divided by 2, which is super easy now, hopefully. And it's going to be 5 hertz. Remember, not just 5. I actually have to write the word or the symbol for hertz, which is capital H, lowercase z, 5 hertz. Finally, we're going to find the velocity of a wave with a wavelength of 8 hertz. With a frequency of 8 hertz and a wavelength of 6 meters. So since we are now finding the velocity, return to our equation. Cover up velocity. We're going to do frequency times wavelength. So that should be very easy for us. V equals F times lambda. Okay, V equals F times lambda. Equals, we're going to fill in the F, that is 8 hertz. And we're going to multiply that by the lambda, which is 6 meters. Okay, and that is going to be our simple times tables. The questions are a little more difficult in the challenge for this week, but I'm keeping it simple here to hopefully let you follow along. Our answer is going to be 48, and 48 what? Well, we're measuring velocity, so it's going to be meters per second. That is going to be our velocity. 48 meters per second. So that is the answer to that last question. Hopefully all of this was helpful for you. If you need extra practice, on this week's choice board, our HyperDoc for this week, you will see that right after this, so you clicked on this video because you were feeling, I'm lost. The next link is going to be extra practice that's optional. It's a green box. Need some practice with waves equations and wave terms? Take a look at the physics classroom for a lesson with further explanations and practice problems. So that's what you're going to be looking at for this week if you need extra practice. If you're feeling good, You can jump straight down to the red box, the learning checkpoint. It's a must-do. And then you're going to be dropping all the way down into the choice boards at the bottom of your HyperDoc for this week. If you have any questions, drop in hours. Our Tuesdays from 10:30 to 11:30 in the morning, and Thursdays from 2:30 to 3:30 in the afternoon. Those links are in your HyperDoc. Drop on by to the Google Hangouts room, or you can, of course, email me. We are all working from home, and so hopefully this lesson has been helpful for you as I teach from home. As always, take care of yourself and each other. Stay safe, wash your hands, and we love you. I will see you guys later.